Yeah, hi, good evening, students. So I hope you all are good. We are going to start from the third unit. Okay, so we have already completed the 2 units and third unit. So whatever I have covered in this video is all the very important questions. Almost have covered all the topics, but whichever the important question topics are there, so that one I have covered and I have marked it as an important. So please go through this video number of times so that you will get an idea. So I'm going to explain it very clearly here, all the topics, so you will get a very good understanding. Okay, so go through this video so number of times. Okay, still if you're having any doubt, you just message me in WhatsApp. Again, I'm going to okay, explain you or yeah, if still if anyone having any doubts regarding this one, I can come to online. Okay, and I'm going to explain. Okay, I'm going to explain the topic. So I will send you a link. You have to accept that link. Through this link I am going to explain you clearly. Okay, so if you are having any doubts, so I hope you will not have any doubts, because I'm going to explain it very clearly in this video. Okay, everything I'm going to explain it very clearly in this video. So whatever topics I'm going to cover here, all are very important. So please go through number of times. Okay, please watch this video number of times. Yeah, so in unit 3 we are going to start from the inheritance topic. So what is inheritance, and explain the types of inheritance with an example. Yeah, in unit 3rd, the first and the very important is inheritance concept. Okay, so first, you need to understand what is an inheritance. So first, what is an inheritance means? Inheritance is the process of creating a new class from one or more existing classes. Okay, so which is termed as an inheritance. Yeah, so till now we wrote so many programs. Okay, till now we have wrote some number of programs in object oriented programming, right? So if you're writing any program here, we have wrote only one program, that is sorry, so we have wrote number of programs. So what I'm going to say means, you have wrote a program, but you have wrote using only one class. So have you used two classes? No. Means okay, for example, different like constructor you or okay, before example, okay, overloading or function overloading or anything. So if you check any above examples, here you have wrote only one class. Okay, so it is not possible to write a program after another program. But in C language, okay, in C language, after writing a one program, that is hash include stdio.h, hash include conio.h, then void main function you are writing. After void main function, you are declaring a variables and you are declaring a function, then you are going to close it. After this, is it possible to write some other part? Means program after program, is it possible? No, it is not possible. But C++ provides us to write a two or more classes also. Okay, not one class, but two or more classes. So first we are declaring one class. After that, below that, again I can declare one more class. So what is the use of this one? So what is the use of this defining these classes means, whatever the first class properties are there, all these properties will get to the second class. So that is useful. Okay, so here simple example. So what is an inheritance means? Process of creating a new class from one or more existing classes. Means two or more classes we are having, we need to understand. Okay, so if it is having two or more classes, then it is inheritance. So creating a class from an existing class is nothing but it is termed as inheritance. So first example, single inheritance. Okay, so in single inheritance, only one base class is used for derivation of a class, and the derived class is not used as a base class. Such type of inheritance between one base and derived class is known as a single inheritance. Okay, so here what I'm saying means single inheritance. Okay, so only one base class is used for derivation of a class. So one base class means, like suppose if I consider X is a class, so only one class will be there, that is X is a base class. And for derivation of a class, okay, one X is a class, base class, and the derived class is called Y. Means whichever the topmost class is there, that is called as base class, and this is called base class. Okay, base class, and Y is called as a derived class. So if I'm having only one base and one derived, then we call it as a single inheritance. Okay, so what is single inheritance means? Only one class inherits the properties of another class. It is called as inheritance, and it is also called as a single inheritance. Okay, this is a common type of inheritance. So only one base class will be there, and only one derived class will be there, and the derived class is not used as a base class. Again, this class is not used as a base class. So this is a base class and this is a derived class, then we call it as a single inheritance. Okay, such type of inheritance between one base and derived class is known as a single inheritance. So this is an example. Okay, even in exam you can draw this one, okay, to show the diagrammatical representation. So here x is a base class and y is a derived class, or we can call it as a x is a parent class and y is a child class. Okay, x is a parent and y is a child. So what why we have wrote like this means, this is an example, x is a base and y is a derived. You should not write as a parent and child, actually you have to write it as a base and derived only. So what I'm saying means, why x is called as parent means, whatever the properties of x is there, that all properties are available to y class. Okay, whatever the properties of x are there, that is available to y class. So property means what? Function. So whatever the member function of x is there, that is available to the y class. Okay, that is available to the y class. Okay, so this type involves one base and derived class. Further, no class is derived from y. Okay, means x and y only two will be there. One is called base, one is called as a derived. So topmost is called base. Okay, bottom is called as a derived. Okay, so is that clear? What is a single inheritance? One base and one derived class is there, then it is called as a single inheritance. So we will write an example for this. Example, hash include iostream.h, hash include conio.h. You know this one. So next, class X. What I have defined? Class X. So in this class X, I have to get as public. So why public I have taken here access specifier? You know why we have taken it as a public means, whatever the okay, whatever we define inside the public, that is available to the below class as well as void main function also. Okay, so why I have taken the here public means, whatever the property is there, that is available to the below class as well as void main function. That's why I have taken it as a public. If you don't write this public, then it is not available to the okay, below class and main function also, means it is considered as a private. So if you wrote it as public, then this function is a public. That is void display is a okay function. So this member function is available to the below class. So class X public void display. And what is the matter we wrote in this? Cout base class content. Okay, because because X is a base class, so cout base class content we have wrote. Means we wrote one member function, only one member function we wrote. So in this one member function, we are writing cout as a base class content. Okay, yeah. So display function. Then I'm closing this class. Okay, X class is closed. Okay, now I'm writing a Y class. So y is a derived class. Okay, you know x is a base class, y is a derived class. So class y column public x. Yes. So what I wrote here means public x. Why I wrote public x here? Why I wrote means public x means, whatever the properties of x is there, that all things should available to class y. So how it will be available when you wrote it as a public x? Okay, class y column public x. Then what property it is having? It is having only one function, that is display function, void display function. So this display function is available, means that display function I can write it in class y also. So I can display it through class y also, means I no need to call a display function. If I'm writing a normal class program, what I have to do? I have to create an object for x. After creating an object for x, what I have to do? I have to call that display function. Okay, how you are going to create an object? With the name of a class. Capital here class x is a capital X. So x, okay, taking it as x, then a small x I will take, that is called as an object I will say. Then x dot display I will use. Means here I have for every class I have to create an object. But if you are using inheritance concept, you no need to create object for, okay, object for every class. You need to create object for only one class. So for which class object you are going to create? Always you are going to create an object for derived class only. Okay, if you create one derived class object, that is enough, because all the properties of X is available to Y class. How it is available? Because we are writing here class Y column public X. So if you write this class Y column public X, then what it is happening actually? So what it is happening here? So when you write class Y column public X, the base function, display function, okay, void display function is there. That display function is available to the class Y. So if I call that display function here in a class Y in one more function, that function base class content will be available for this Y class function. Okay, so in class Y public X, again I am defining a void disp function. Okay, what is this? Void disp function. Okay, so void disp function I'm writing in this void display function. Okay, so this void display function, okay, yeah, this one is also public. Okay, so public, so class X is public, class Y is also public, but class Y column public X means what happened? This display function, okay, whatever this display function is there, this is available to class Y. So here in class Y also I'm defining one function. So what is that function name? Disp. Okay, I'm defining instead of this display, I'm writing disp. Okay, because display will become both, so that's why I'm writing in class I'm using disp function. In this disp function I'm calling display function. So display function is whose function? Display function is a class X function, means base class function I am calling here. Now what happens if I create object for this class Y? That is enough. Okay, if I create object for this class Y, okay, what happens? That this function display function is also available, this disp function is also available. With the help of one Y object I can call this a disp function. This disp function is calling display function. Okay, okay, so wait, okay, so see, okay, to clearly understand what I'm going to do means I'll copy this one, I'll take it to paint. Yeah. Mhm. Yeah, I hope you all can see my screen, right? Mm, yeah, yeah. So listen now properly. So what is an inheritance concept? What is an inheritance concept means writing a class, okay, or defining a class more than one is nothing but it is called inheritance. Or what we can define, uh, okay. So yeah, so what is a inheritance? Defining a more than two classes is nothing but it is called as a inheritance. In this single inheritance. So what is single inheritance means? Okay, so yeah, so what is single inheritance? So here, okay, two classes. If I define two classes, it becomes a single inheritance. Okay, so this one is one inheritance, and second one is okay. This one is called class X is called as a base class. Okay, this one is called base class. Okay, and this one is called derived class. This one is called derived class. Okay, now in this main function, okay, okay, so this is the main function. Okay, yeah, so this is called base class, this is called derived class. Now what happens means here this display function is there. Okay, so this display function is available here. Okay, how it is available? Because I'm calling this display function in class Y. Okay, so see here. So what I'm going to do means I'm going to draw this one like this. So this display function is available here. Okay, is that clear? Sorry. This display function is available here because I am calling that function here. Clear? Here I am calling it display function. Okay, so that's why I'm calling this here, this function. This display function is available here. No, okay. So now if I create an object for this class y, okay, if I create an object for this class y, that is enough. So where I'm going to create, I'm going to create here. See, look here. So y, okay, y, capital Y is the derived class, okay, derived class y, and small y is an object. So here, okay, I'm creating an object. Okay, so small y is object. Small y is object. Now what happens? What I'm calling here using y. What I can call y class object, y class function only I can call. So disp is the function which I am calling. Okay, so I am calling disp function. So what is this disp function? Second object, second object. Okay, so I mean second class object. Okay, so I'm calling disp, that is second class object. I'm calling this function, that is second class object. Okay, okay, I hope you all understood. Okay, so what is inheritance? Inheritance is nothing but creating a one or more class from an existing classes. So class X is a one class. So with the help of this class X, okay, so class X is one class, then I'm creating one more class, that is class Y. So creating one or more classes from an existing class is nothing but it is called as inheritance. Okay, so in this inheritance concept I can define any number of classes, but I'm creating an object for only derived class. Okay, I'm creating an object for only derived class. Okay, so this is class Y is a derived class, class X is a base class. Now what is the purpose of this inheritance? So whatever the function in base class is there, that should be available to the derived class. So how it will be available to the derived class? By using this one. Okay, after writing a second class I have to use column public X. So publicly I'm accessing this one. Okay, so you have understood. If I keep here private, then what happens? I cannot able to access this class properties here because I'm using public X. Whatever the function display function is there, that is available to the class Y. So if I use private X here, then what happens? This class will not be available to the class Y. Okay, so that's why I'm using class Y public X. Now if I use public X, this property will be available to this class. Okay, as well as protected is also there. So if I use protected, this function is also available to this class. But if I use protected, what happens? It will not be available to the main function. Okay, if I declare it here as protected instead of public, if I declare it as protected, the display function will be available to class Y, but it will not be available to the main function. Okay, so we'll come to learn about this access specifiers in next topic. But now you need to understand that. So first class X properties should get to class Y. So how it is getting? By using this. Okay, class Y column public X I have wrote. So if I wrote this class Y column public X, so this void display function will be available to this class Y. Okay, so now I am saying it is available. So if it is available, what I have to do then? I have to call this function. This is a member function, this is not a constructor. So if it is constructor, we no need to call, but it is a member function, we need to call. So to call this member function, I'm using a second class. In second class again I'm using a one function called disp function. Okay, I'm using a disp function. I'm using this disp function. Using this disp function, okay, inside this disp function I'm calling a display function. Okay, inside this disp function, I'm calling this display function. Now if I call this only this disp function, that is enough. If I call this disp function, that is enough. Okay, so how I can call this disp function? If I create object for y class, I can call this disp function. So after creating an object for y, I will call y.disp function. But inside this disp function, what is there? Display function is also there. So it will display both display function base class content output as well as derived class content output. Now what I have avoided, what I have avoided means I'm not creating an object for class X. So this is the advantage of inheritance. If I use inheritance concept, how many classes also I want to use, I can use, but I'm going to create an object for only one class. Which class object I'm going to create? Derived class object. Okay, only derived class object I'm going to create. How many base classes it may have, but if I create only one derived class object, that is enough. Okay, so whatever the class X function is there, that will be available for the derived class. Now derived class object I will create. Okay, by this what happens? Time will be reduced, as well as memory space will also be reduced, because I'm creating only one object. Okay, because I'm creating only one object, though I'm having two classes, I'm creating only one object. But what is the rule in object oriented programming? Whatever class you define, compulsory you need to create an object for it. But here in inheritance concept, how many classes it may have, but you are going to create an object for only derived class. So you are going to create an object for the derived class. So y is an object. Okay, that is derived class object. So capital Y is the name of the class and small y is known as a object. Okay, small y is an object I have used, capital Y is the name of the class. Instead of student, instead of employee, what I have created here, class X and class Y. Okay, simply I have to took only class X. Okay, X is the name of the class Y. Okay, Y is the name of the class. Okay, so class Y column public X. Okay, if I say public X, so whatever this display function is there, that will be available for class Y. Now I will create an object for this class Y. Then what happens? This disp function will be called. Inside this disp function, again display function will be there. Means the control will go from here to here, and automatically from here it is going to here. Okay, see. So now what happens means, if I execute here, okay, so I'm creating an object for second derived class, and here I'm calling a second class, that is derived class object. I'm calling derived class function, I'm calling y.disp function. So if I call this disp function, what happens? The control will go from here to here, it will go. Okay, disk function it will go. So after going this disk function here, inside this disk function, what is there? Display function is there. So this display function it will call. So this display function it will call means, again control will go from here to here. If it go from here to here, now what output is there in this display function? Base class content. So first base class content will be displayed as output. Second, it will display as a derived class content. Okay, first it will go, control will go to display function. Again it will return back to this function. In this function, what is second statement is there? Derived class content. Means first base class content it will display, second it will come and it will display derived class content. Okay, now understood. So what is an inheritance concept? Defining a class. Okay, defining a class means what we say, defining a class from an existing class. So okay, defining a class from one or more existing classes is nothing but inheritance. Okay, in this inheritance concept, first type of inheritance is single inheritance. In single inheritance, you will have only two classes. First class is called as a base class, second class is called as a derived class. So base class, derived class means what? Whatever the properties of always base class will be there, that is available to only derived class. Okay, so so whatever the properties means, whatever the functions, okay, whatever the functions are there in X class, okay, base class, that will be available to the derived class. Okay, so this is a single inheritance. So here in base class you are having one display function, what display function? This display function will be available to the, okay, derived class. Okay, clear? This is a single inheritance concept. Okay, so we'll see through we'll see it through program. Okay, Okay, so I hope you all can see my screen, right? Mm, yeah, this is single inheritance. Okay, so look here. First, hash include iostream.h, hash include conio.h, class X. Okay, class capital X. Okay, capital X is the name of the class. Public. Okay, access specifier public. Okay, why I'm using public? So whatever whatever function I write in the below this public access specifier, that will be available to the main function as well as below classes also. If I keep it as here public, so this below is display function, so this display function will be available to the below class as well as main function. That's why I'm using a public access specifier. In public access specifier, void display function. So void display function, in display function what I put output, I took base class content. Okay, base class content I took. Next, class y public X. Okay, so class y is a derived class. Okay, so class X is a base class y is a derived class. So public X I am writing. Okay, after class y column public X I am writing. So whenever you write class y column public X, the property of X class will be available to Y class. Means the function of the member function of class X will be available to class Y. What is the member function here? What is the member function name? Display function. So this display function will be available. Okay, this display function will be available to class Y. Okay, so we up to where this display function? Up to here. Okay, so these three lines, one display function, cout base class content, all this will be available to this here in this class. Now in this class Y, again I'm creating a okay one more function, that is disp. So before writing this function, what I have access specifier, I wrote public. So if I take this, if I write this public access specifier, this will be available to the main function. That's why I'm writing it as public here. Public void disp function. In this again I'm calling a display function. So this display function is a okay, this display function is a base class member function. Okay, so this one is a base class member function. Okay, display function is a base class member function. Okay, this is base class. Always first class is called base class. Okay, this second class is called as a derived class. Here capital Y is derived class. Always we are going to create object for derived class only. Okay, so this is a base class member function, and disp is a derived class member function. Disp is a or disp function is a derived class member function. Okay, clear. After this we have closed this class Y. First we have closed class X, next I have closed class Y also. Now two classes I wrote. After writing these two classes, I'm creating object for it. Void main function, clear screen, capital Y, small y. Capital Y is the name of the class, small y is an object for class Y. Capital Y, small y. Then I'm calling small y dot disp. So if I say small y dot disp, okay, this display function will be called. Okay, get ch. I will see control F, see an output. Yes. So the output is base class content and derived class content. So okay. So what happened here? I haven't created object for class X, but I have created object for only Y class. But still, it is it is displaying the base class content. Means if I create object for the derived class also, it will show the output of base class also. What is the base class output we are having? Base class content. Okay, so the base class content base class content means base class output is in base class only, that it will be displayed. Okay, so this is a single inheritance. Okay, I hope you all understood this one. So we'll move forward. Okay, Yes. After the single inheritance, we'll be going for our next type of inheritance. So altogether, how many types of inheritances we are having? Single, multiple, okay, multi-level, hierarchical. Okay. Altogether, 5 inheritances we are having. We'll see one by one. After completing this first inheritance, single inheritance, we'll go to multiple inheritance. So in this multiple inheritance, when two or more base classes are used for derivation of a class, it is called multiple inheritance. When two or more base classes. See, in multiple inheritance, what do you mean by multiple? Multiple means two. So two what here? Two what means we are having two base classes. Okay, two means what? We are having two base classes. Okay, so in multiple inheritance we are having two base classes. Yeah, so here x and y are base classes and z is a derived class. Okay, we are having two base classes and one derived class we are having. So what already we have understood, whatever the properties of base class is there, that will be available to the derived class. So whatever function we write in x function, whatever function we write in x class and y class, okay, so that will be available to the z class. Okay, so whatever functions we write, okay, whatever functions we write in x and y classes, that will be available to z class. Okay, now understood. The same concept like single inheritance, but in multiple inheritance we are having only two base classes, one derived class, whereas in single inheritance we are having only one base class, one derived class. In multiple inheritance we are having two base classes, one derived class. There in below example we will see x and y are the base classes, z is a derived class. Class z inherits the properties of both x and y. Okay, so see, class z inherits the properties of x and y. Okay, inherits, what do you mean by inherits? Inherits means getting the property of x and y. So what is a getting the property? Whatever function you write in x and y, that will be available to z class. Okay, so z is not used as base class. Again, z is not used as a base class. See, so z is only derived class, means I can create an object for z, that is enough. If I create an object for z, both the properties of x and y will be available to z. Okay, like previous example only. See here, hash include iostream.h, hash include conio.h, class x, public void display function. Okay, control C. Okay, see, uh, again I have taken this one in paint so that I can clearly explain you. So hash include iostream.h, hash include conio.h, class x, public void display, base class content. Now class x is a which type of class? Base class. And class y is a base class. Two base classes, one derived class. So class z is a derived class. So class x is a base class. In base class we are having one member function. Okay. See, first base class. Okay, it is a first base class, and this is a second base class. Okay, second base class. Okay, so now in this having, in first base class we are having one member function. Okay, that is display member function. Okay, yeah, here in class y also we are having member function, disp function. Now both this display and this both will be available to class z. Okay, so here first base class, second base class, first base class x. Okay, first base class X, second base class, okay, Y, and third one Z. Z is a what type of class it is? Derived class. Derived class Z. Okay, so Z is a derived class. So we are having two base classes and one derived class. Okay, so if I am having two base classes and one derived class, then it is called as a multiple inheritance. Okay, multiple. What do you mean by multiple? Means two base classes, one derived class is called as a multiple. So here class Z we are having, okay, public X comma public Y. Now if I say public X comma public Y, both the properties means display function as well as disp function, both functions are available to class Z. Okay, because we are going to create an object for only class Z. So if I want to create an object for only class Z, now if I'm creating object for only class Z, both properties, both classes properties should be available. So if both classes properties should be available means I have to define both functions here. So I am defining display function and disp function in D function. So D function is, okay, what is this D function? D function is a derived class function. Derived class function. This is derived class function. Function. Derived class function. Display function is a first base class function. First base class X function. First base class. Okay. What is the first base class name? X. First base class X function. And disp is a second base class Y function. Now if I create, okay, so now if I create object for this one, okay, if I create object for this Z class, that is enough. Both classes X and Y will be called automatically. Okay, so see, void main function, I'm creating object for class Z. Okay, and Z dot D function I'm calling. So D is the derived class function. If I call D function, first what happens? Control will go. Okay, control will go from, control will go from here, from D function, where it will go from void main function to, it will go to class Z. In class Z, where it will go? It will go here. Okay, it will go to D function. After going to this D function, okay, what is the first statement it will execute in D function? Display function is there. Now the control will go from here. The control will go from this class to first class. So if it has to go from here to here, okay, what access it should have? It should be public. Okay, here it is having public, right? Public access it is there, so it will go to public. Okay, because it is having public, the control can go from here to there. It will go from here to, there is a display function here, it is there, it will go to display function and it will execute first base class content, it will execute. Clear? Next, second, what we are having? Oh, I hope you all haven't seen the screen, right? I'm continuously explaining here, but you all can't see my screen, right? Now you all can see my screen, right? Okay, so what is multiple inheritance? What is multiple inheritance means? Defining two base classes and one derived class. Here two base classes is class X and class Y. Okay, class X is a base class Y is a base class, second base class, and class Z is a derived class. Now first base class is first base class of member function is display function. Okay, I will explain. See, so the first base class is X, second base class is Y, then derived class is Z. So now if I create an object for class Z, that is enough. So how I am going to create an object for second class? Capital Z, small z. Capital Z is the name of the class, small z is an object. Okay, so I'm creating a object for derived class. Okay, small z is a object of derived class. Derived, okay, z is a object of derived class. Okay, z is a object of derived class. Next, what I'm going to do, I'm going to call this in z class. I'm going to call a member function. So in z class, if I'm going to call a member function, then the control will go from z function to, okay, z class d function, means it will go to here. After going to this d function, what is the first statement it has to execute? Again, display function it has to execute first. So the control will go to display function. So if display function is there, so where this display function actually, it is in class X. Now again the control will travel from here to, okay, the control will travel from here to here to here. Okay, void display function, and it is going to display base class content. Again, next what it has to execute, it will come out of that first class. After coming out of the first class, it will go to this second statement, disp function. So where is this disp function? The control will travel from here, and it will go to, and it will display this disp function. It will execute this disp function. In disp function, what you are having output, second base class content, means first it is going to display base class content, second it is going to display second base class content. After displaying this second base class content, again control will come here. After control will come here, again one more statement is there, derived class content. It will display derived class content. After displaying derived class content, the control will come out of the, okay, come out of this z class. After come out of the z class, it is having one more statement, get h. It is going to show the output. Means here, how many classes we are having? Three classes, x, y, z. If I'm having three classes, I have to create three objects. Okay, I have to create first class object, second class object, third class object. No, but I am not creating a three classes object. I'm only creating a z class object. Why? Because derived class it is. Derived class means what? The properties of base classes will be available to derived classes. So what are the properties of base classes? Display function and disp function. So this display function and disp function will be available to derived class. So if I define this, if I call this display and disp function in z class, okay, and if I create an object for z class, then that is enough. So how much memory it has saved? See, okay, so I'm calling, okay, sorry. So what I'm going to do means, I'm going to call only z class. Okay, I'm going to call only z class object. Okay, this is a z class. If I suppose this is a z class, okay, so z class object I'm calling. In this z class object only, I'm having, okay, in this z class object only, what I am having, I'm having both class X and class Y. Okay, so this, uh, okay, suppose we call this one as a class X. Okay, this is class Y, and this is class Z. So if I am creating an object for class Z, okay, capital Z, small z. If I'm creating this object for this small z, okay, if I'm creating an object for this one, so, okay, so first it will go and it will call this z function. Now this z class, uh, okay, whatever function is there, member function, it will go from here and it will call to class Y function. Okay, after this, again in class z only, we wrote one more member function, that is, okay, disp. So it will go and it will go to class X and it will call this class X function. First it will call this class X function. Again it will call class Y function, and it will call and it will execute its own function, class Z function. It will execute means it will travel from class Z to class X. Again from class Z to class Y it will travel. Again it will display the class Z also. Okay, so why it is how it is possible to move from class Z to class X? Because we have taken it as public. Everything we have taken it is public. In class Z, public X, public Y, and class X also we have declared it as a public. In class X, what access specifier we took? Public. Okay, in class Y also we took it as public. See, we'll see here. Okay, in class X we have taken it as a public. Okay, as well as in class Y also we have taken it as a public. So because we have taken it as a public access specifier here, okay, so the Z class is having access to these both classes. Okay, if the control has to move from Z class to another class, it require this one. Okay, if we are having public X comma public Y, then only it is called as a derived class. Okay, so the properties of X class will be available to Z class, the properties of Y class will be available to Z class. Okay, so how we can recognize derived class? Class Z column public X will be there. For every derived classes, this statement will be there. Based on this statement, we can identify this is a derived class. So derived classes will inherit the properties of base classes. So here the derived class is class Z, and public X and public Y is a base classes. Okay, so both base classes properties it will inherit. Clear? I hope you understood this one. I have explained very much clearly. Okay, so we'll see through uh, program. Multiple. Okay, see, this is a multiple inheritance. Hash include iostream.h, hash include conio.h, class X. Okay, base class. Class X is a base class. Okay, base class, or we can write first base class. Because two base classes are there, we'll consider it as a first base class. Okay, first base class, and class Y is a second base class. Second base class. In base class, first base class, we are having display member function. In second base class, we are having disp function. Okay, again we are declaring this one derived class. So what is the name of this derived class? Derived class. Z is a derived class which inherit the properties of X and Y both. X and Y is a base classes. In derived class, I have declared public void D. Okay, this is a member function we are having in a Z class. Void D is a member function of class Z. So if I call this D function, it will call both display and disp function. Okay, the control will move from this from D function to display function. Okay, the control will move from again disp function, it will move. So first it is going to display function, later it is going to display disp function, and later it will display this derived class content. Okay, clear? Shall we see the output? Okay, see, we have created the object for Z class, Z small z, Z dot D function. We are calling this D function here. Okay, so this is a derived class object. Though we are having three classes, we are creating an object for only derived class. We are creating only derived class object. Using this derived class object, the contents of both base classes will be displayed. Okay. Yes. Yes. First base class content, second base class content, next third one derived class content. So first base class content, this output is in first base class, that is X class, and second base class content, this output is in Y class, that is second base class, that is Y class. Derived class, Z is a derived class. So first it is going to display X class output, next it is going to display Y class output, third it is displaying a Z class output. Okay, so if I create only object for one derived class, so clear. So I hope you all understood this multiple inheritance. So shall we go to next topic? Yes, hierarchical inheritance. So what is this hierarchical inheritance means? When a single base class is used for derivation of two or more classes, it is known as hierarchical inheritance. So when a single base class is used for derivation of two or more classes, it is known as hierarchical inheritance. So here we are having one base class, three derived classes I am having. So now if I am having three derived classes, how many objects I have to create? I have to create three derived classes objects. I have to create. I have to create X class object. I have to create Y class object. I have to create a Z class object. See here, this hierarchical inheritance is a simple example. See, like one parent is having three children. Now, if one parent is having three children, the property is given to only one children, or it will given to three children's. It will be given to three children's. Okay, it will be shared equally. So here, see, W is a parent class. If I consider X, Y, Z are the child classes. Now, the property of W will be shared for all the three classes X, Y, and Z. Now, in W class, we are having one display function is there. That display function will be available to X class, the display function will be available to Y class, that display function will be available to Z class as well. Okay, as well as Z class will all XYZ will also having its own functions. It will have own function, as well as W class function will also available to X, Y, and Z. Okay, the property will be shared by all the three classes. So in hierarchical inheritance, altogether how many classes we are having? Four classes. Now what is hierarchical inheritance? A single base class will be there and two or more classes, okay, derivation classes will be there. Means a single base class and two or more derived classes are there, then we call it as hierarchical inheritance. Okay, so what is hierarchical inheritance? It will have one single base class and two or more derived classes. Okay, one base class and two or more derived classes are there, then it is called as a hierarchical inheritance. So W is a only one base class, X, Y, and Z are derived classes. Further, X, Y, and Z are not used for deriving further more classes. Okay, X, Y, Z are not derived. So if X, Y, Z are not derived more, then it is called as a hierarchical inheritance. So the see below example, first we are having only class W, that is a base class, and we are having class X, Y, and Z are the derived classes. Okay, so okay, I'll show this example again. Please listen these videos 2 or 3 more times so that you will understand it clearly. Okay, okay, this is a hierarchical inheritance. So see, so what is hierarchical inheritance? So always draw this diagram. So if you draw that diagram, okay, wait, I'll do one thing also. If you draw this diagram, okay, okay, so I hope you all can see my screen, right? Yeah, so see, so hierarchical inheritance, in hierarchical inheritance always draw this diagram. Based on this diagram only you can draw. So first always the base class will be at top, and below are the derived classes. So hierarchical inheritance means what? One base class will be there, two or more derived classes will be there. So in this present example, I'm taking one base class, that is w. So I will write one member function in this w that will be available to all the three. Okay, that function will be available to x class, that function will be available to y class, as well as that function will be available to z class. So what function I am writing in w class? Display function. Okay, so this display function will be available to all the three classes. Okay, so see, void display function base class content class x public w. Okay, what I wrote? Class x public w. Why? Because x is a derived class. If it is a derived class, what I have to write? If it is a derived class, what I have to write? I have to inherit the property. Okay, if it is a okay, if it is a derived class, I have to inherit the property of w. Okay, so class x column w. So here display function is there. Void disp function I'm declaring is disp function. In disp function I'm writing display function, means the control will go from here to here. If I call this disp function, the control will go first, it will go to first statement, it will execute this display. Where this display function? It is in base class, so it will execute this display function. Okay, and it will come and it will execute this first derived class content. Second, again, next it will go to y. Okay, class y public w, and class y public w, class y public w, public void d function. I have used your disp function, I have used your d function. In d function again I have used base class member function, that is display. Okay, see out second derived class content. This is a second derived class. Okay, class x is a base class, sorry, class w is a base class, and class x is a derived class, and class y is a derived class. Three derived classes are there, means I have to create three objects x, y, and I have to create x, y, and z object. I have to create. Okay, class z. This is also derived class. Okay, derived class. So see, void main function x. I'm declaring here. I'm creating first derived class object. So if I create this okay, this object, what happens? The control will go from x dot display from here to where it will go. Where is x class? Yeah, the control will go from here to here. After getting here, what is there here? Display function is here. Again the control will go from here to here, means the first it is going to display base class content. Next what it is going to do, display first derived class content it will display. Again next y class object I have created. Y class object I have created y dot di I said. So the control will go from here to where it will go. The control will go from here to here. Sorry, here it will go. Okay, d function it will go. Okay, next here d it should be there. Some printing mistake. Next to z di means it will go from here to here. So after going both the places, first it will display the first what it is going to display: base class, first derived class, base class, second derived class, base class, third derived class. Means the three derived classes got all the properties of base class. Okay, so see, we'll see it as program. Hierarchical entities. Okay, see, hash include iostream.h, hash include conio.h, class w. This is a base class. Only one base class, one base class, three derived classes are there. Okay, then it is called as a hierarchical inheritance. This is first derived class, second derived class. Hmm, somewhere something went wrong in this here. See? Hierarchical inheritance. Yeah, here some public w. Okay, so class X will inherit the properties of derived class will inherit the properties of base class. What is base class here? Base class is w. Okay, some addition I have to make it class Z public w. Okay, so this is first base class, first derived class, second derived class. This is third derived class. Now whatever the function, whatever the member function is there, base class member function, that it has to be called here. So I didn't write here function name. See, DSPLAY display function. Okay, now what happens? First it is going to display function, again it is going to display disp function. Here also in D function also I didn't wrote, and here also I would use SPLAY display function. Here I wrote, okay, okay, so display function. So now I'm going to create an output for all the classes X, Y, and Z. Capital X, small x, column X dot. Sorry. In X, what function name we are having? In X, we are having disp D and Di. Okay, disp. Okay, next I'm creating Y class object. Y dot sp Di, right? Disp Di. Sorry, disp D and Di. Disp D and Di. Z dot Di. Okay, three have created objects. First I have created X. Okay, X is a derived class, first derived class. So I have created first derived class object X dot is function. Second I have created a second derived class. Okay, Y, small y dot D function. Again Z class, Z dot. So all these three objects will have the property of first base class. Okay, first base class. In first base class, what we are having? Display function. All the three, first it will display function, again it will go. Okay, first we are going to save this one, save. Mm, so control F9. Oh, errors, two errors. Statement missing. Yeah, semicolon. Okay. Control F9. Yes. See, base class content, second base class content, base class content, third base class content, base class content, derived class content. Okay. No, no. Second outputs we wrote wrong. We'll edit. See what I wrote here. Base class. This is second derived class. Sorry, first derived class. First derived class. First derived class. Second derived class content. This is third derived class content. Okay. File save. Now we'll see the output. Yes, base class content, first derived class content, base class content, second derived class content, base class content, third derived class content. Understood? This base class content is a base class output. First derived class is content is a first derived class, okay, output. Okay, base class content is a first base class, second derived class, first base class, third derived class. Means three derived classes, only one base class is there. All the base means one base class output will be displayed to the all the three. Means okay, property of first base class will get to the all the three classes. Clear? I hope you all understood this. Okay, if you're having still, you go through this video number of times so you can easily understand. Okay. We'll continue for the next topic. So I hope you all can see my screen. Hierarchical inheritance is completed. Next is multi-level inheritance. So what is multi-level? When a class is derived from another derived class, that derived class acts as a base class. Such type of inheritance is known as multi-level inheritance. Means here how many base classes are there? How many base classes and how many derived classes? We'll see. First, X is a base class. The property of all X will be available to Y class. Again, Y class will become a base class for Z class. So all the properties of Y class will be available to Z class. Okay, this is a multi-level inheritance. Means X property will be inherited by Y property will be inherited by Z. This is multi-level. Okay, what is multi-level? Because it is in line, we call it as a multi-level inheritance. All the properties of X will come to Y, all the properties of Y will come to Z. This is how means small example. Okay, real-time example. If your grandfather property will come to father, father property will come to son. So X is a grandfather, Y is a father, Z is a son. So all the grandfather property X will come to father, father property will come to son. So this is a simple example. Okay, X, Y, Z. We can remember like this. Multi-level inheritance means what? Okay, the properties of X will come to Y. Okay, all the property of X will come to Y. The property of Y will come to Z. That is multi-level. Clear? So see, X is a base class, Y is a derived from X. Further, Z is derived from Y. Okay, Z is derived from Y. So here Y is not only a derived class, but also a base class. So Y is what? Derived class as well as base class. Both. Y is what type? It is base class as well as derived class also. Okay, so Z can be used as a base class. Here Z can be used as a base class. So in this present example, here Y is a both base as well as derived. Why? Because X to Y, Y to Z. So Y will act as a base class for X, and Y will act sorry, Y will act as a derived class for X. Okay, and Y will act as a base class for Z. So it is a multi-level. Means Y is both base as well as derived. Okay. Control C. Again, we'll go to paint. Okay. I'll share screen. Okay. Mm, I hope you all can see my screen. Right. Okay. So see, this is multi-level. So multi-level means X to Y, Y to Z. Okay. See here, I'll show you. X, X property will come to Y, Y property will come to Z. This is multi-level. Always draw diagrams so that you can remember them how to write programs easily. X, Y, and Z. X, Y, and Z. Okay. So here X is a base class. Obviously, every first class is called as a base class. So here X is a base class. Now Y is a base class as well as derived class. Okay. Okay. So X to Y, Y to Z. X is a base class. Y is a, okay, X is a base class, and then Y is a both derived as well as, X is a base class. Y is a derived class. Okay. Yeah. So what happens means here, okay, whatever the X property is there, it will come to Y. Now whatever the Y property is there, it will come to Z. Now directly you can say whatever the X is there, X property will be there, that all will be available to Z. Yes or no? X property will come to Y, Y property will come to Z. So obviously X property will come to Z as well. So that is what XYZ is, a multi-level inheritance. Okay. So how we can define this? So here one thing we need to understand, what is that means. Okay. What is that you're going to understand here? One thing you need to understand here. Okay. So what is that means? Y is, here Y is both base class and derived class. Okay. How? So for X is a base class, Y is a derived class. For X, Y is a derived class. For Z, Y is a base class. Okay. So always top class is called base class, below class is called as a derived class. So X is a base class, Y is a derived class. So Y is a base class, Z is a derived class. In this way, okay, what we can say, what we can say, Y is a both base and derived class. So we'll see this example, class X public int X. So what I'm going to do means, now instead of taking output C out every time, I have declared one variable index. Okay. So I have declared one variable called index. So uh, so here also, if I create an object for Z, that is enough. It will get all the properties of Y and X as well. Okay. So int X I have taken, I have closed that class X. Class Y public X. Okay. Why I'm taking here public X? Okay. Why I'm taking this here public X? So if I take this public X, what happens? Okay, if I take this public X, what happens? The property of X will be available to class Y. Okay, int X, int Y. So here it should be public as well. Okay, now class Z I have taken. In this class Z, public X I have taken. Uh, public Y I have to take here. Sorry. Here I have to take class Y, public Y. Okay, class Z, public Y. Okay, this property it will take. So in this class Z derived class, okay, so here class X is a base class, class Y is a both derived and base, both derived and base. Okay, derived for class X, base for class Z, and class Z is a only derived class. Derived class Z is a derived class. Okay, so in this class Z, what I have taken, I have taken get function and put function. In get function, what I have taken, see out, enter the value for X. Where I have defined X, I have defined X in a base class, and I have taken C in X. See out, enter the value for Y. So Y where I have declared, I have declared in Y class. So C in Y. Okay, Y. Okay, so we are getting a values from X and Y from class Z. Okay, X and Y values I'm giving in a class Z. Okay, and put function. In put function, what I'm going to do, I'm going to display C out X equal to X, C out Y equal to Y. Now I'm going to create an object for Z class, that is derived class object. Z small z, Z dot get function, Z dot put function. If I say Z dot get function, what it will happen, the control will go from here to here. After going here, what it will do, see out enter the value for X. Okay, now I have to enter the value for X. I will give some 10. Okay, so now if it to go the function, the control goes to get function. First question it will ask, where is X? It will ask. So where is X? X is in class X only. So X is in class X. That's why in class X I have defined int X. So the int X will come to Z obviously. Next, class Y, C in Y I said. So where is Y? Y is in, again Y is in, okay, Y class. Y is in Y class. The value will be getting from Y class to Z class. Okay, so Z dot get function, Z dot put function I've said. Okay, we'll see through program now. Okay. Multi-level. Yeah, this is class X public int A. This is a first base class. Class Y. Class Y is a both base class and derived class. Public X, public int B, class Z. In Z, what I said, public Y, public void get function. Enter the value for A, C in A. C out, enter the value for B, C in B. Okay, I closed void get function. Next void put function. C out A is equal to A, C out B equal to B. I have closed void main function, clear screen. Z is equal to Z, Z equal to get function, Z dot get function, Z dot put function, get CH. Okay, clear? See, shall I execute this program? We'll see. Okay, so I'm going to create the object for Z class only. Yeah, enter the value for A. So where this one, A is where it is in base class. So I'm giving a value for base class. Now enter the value for B. Where is B? B is in Y class. So Y is a both, Y is a both base and derived class. I'm giving a value. Clear. A is equal to 10, B is equal to 20. Where is A is equal to 10, B is equal to 20? It is in Z class. So now enter the value for A is a grandfather, enter the value for B is a father. A is equal to 10, B is equal to 20 is a son. So son got both 10 and 20 values. Okay, 10 is a grandfather's property, 20 is a father's property, and son got a is equal to 10, b is equal to 20. Okay. So this, okay, ends the multi-level inheritance. Okay, so I feel you all are getting bored, but we don't have any other option. Okay, so you take break and listen again, but I don't have I have to continue this one. I should not take break. If I took break, then it will like, okay. So see, okay, I will. mm, Next is hybrid inheritance. So what is hybrid inheritance? The combination of one or more type of inheritance is known as hybrid inheritance. Okay, the combination of one or more type of inheritance. So what is hybrid? Always hybrid means two combinations is called as a hybrid. In plants also we say hybrid plant. Why we say hybrid plant? Because we are combining two plants. Okay, one plant will be there. Okay, we will attach another plant to it, to its branch. Okay, then we will, okay, we'll surround it with tape, then we call it as a hybrid plant. Similarly here hybrid means two combinations is nothing but hybrid. So what all two combination we are having? Just now we have learned multi-level as well as single inheritance. Both multi-level and single inheritance together is called as a hybrid inheritance. C X, Y and W. Okay, this is multi-level. Z and W, this is single inheritance. So this combination is called as a hybrid inheritance. In hybrid inheritance, altogether how many classes you will get? Four classes you will get. Here X is a base class. Y, again Y is both base as well as derived. Derived class for X, base class for W. Okay. Okay. So top class is always called as a base class. So W is a Y is a base class for W. Okay. And Z is also a base class. Z is a base class, W is a derived class. So in this type of two type of inheritance is used, single and multiple inheritance. Class Y is derived from class X. It is a single type of inheritance. Further, the derived class Y acts as a base class. The class W is derived from the base class. Okay, so program you can write. Okay, you write the both multi-level as well as single inheritance program. If you write, you'll get based on this diagram you can write the program easily. Okay, no need to worry. Next, multi-path inheritance. So this multi-path inheritance is a very important program. So this multi-path inheritance program is virtual program only. In next topic you will come to know what is virtual program and all this. So what is multi-path inheritance means? When a class is derived from two or more classes that are derived from the same base class, such type of inheritance is known as multi-path inheritance. Okay, you can write virtual program for this. Virtual program is the next topic. Next, after two topics we'll have virtual program. If you write the same program here, that is enough. I will explain multi-path inheritance. Okay, there. Here we are having a one base class, two derived classes I am having. X and Y are the derived classes. Again, both X and Y derived classes will act as a base class for Z class. Understood here? One base class W. From this base class W, we got two derived classes X and Y. Okay. From these two derived classes X and Y, again called we got one more derived class, that is Z. Okay, so Z is a derived class for both X and Y. Okay, so Z is a derived class for both X and Y, means X and Y will become a base class for Z. Z is a derived class from X and Y means what? X and Y is a base class for Z. Okay, so W is a base class, the class X and Y are derived from W. Okay, both X and Y inherit the properties. Clear? So by this we end the inheritance concept. Okay, multi-path inheritance. Okay, so see, in multipath inheritance what happens means, W is a base class, the class X and Y are derived from W base class. Both X and Y inherit the properties of class W. Further, the class Z is derived from X and Y. X and Y have the same copies of members inherited from W. Here the ambiguity is generated, hence the virtual keyword is used to avoid the ambiguity. Okay, so what do you mean by ambiguity here? Class Z is derived from X and Y. X and Y have the same copies of members inherited from W. Yeah. So see, from X, what function you will get? W function it will get. Y also will get a W function. In z, again both x and y function it will come. If both x and y function it will come, the both function will become a ambiguity. Okay, see here, from w, one person is having two sons. He has given the property to both x and y. Both x and y is having only one son. Now x is giving the same property to z and y is also giving the same property to z. So that type of ambiguity it will occur. Understood? uh, okay, see, so w will have the one function named display. That display will give to x, as well as that same display will give it to y. Now z will inherit the properties of x and y. Z will get the both display function. Now two times it is getting the same function name. That is called ambiguity. Okay, what ambiguity it will arise means the same function name it is getting from x as well as y. If same function name it is getting, it is called ambiguity. So to avoid this ambiguity, we are using the virtual keyword. If I use virtual keyword, okay, so the ambiguity will not come. So that we will see in a okay, virtual program. Yeah, next topic is access specifiers. Define access specifiers, explain public, private, protected keywords. Okay, access specifiers already I have mentioned. There are three types of access specifiers: public, private, and protected. Okay, this is also a very important question. So first important question is inheritance, second one is access specifiers. So now whatever I have taught in inheritances, they are not going to ask whole inheritance okay, briefly mention all the inheritances with their examples. They are not going to ask. For short questions they will ask either single, either multiple, or multi-level, or hierarchical they are going to ask. Okay, for short answer. For long answer, if they say what is inheritance and explain types of inheritance, you have to write the definition, you have to write the diagrams for inheritances, and you have to write two or three programs. Okay, single, multi-level, multi hierarchical, if you write, okay, that is enough for long answer. So most of the time it will come for short question answers itself. Okay, so no need to worry, but learn all the inheritances as I have explained. Very easy programs. Try to practice. If you're having systems, please practice. Okay, so if you are having mail, send it to mail. I will send a software for you, C++ turbo C++ software for you. Okay, so that you can practice. Yeah, next is access specifiers. First is protected member and class access. Okay, so you can declare a derived class from a base class with different access control specifier: public inheritance, protected inheritance, or private inheritance. Access specifier defines the scope of members of base class into derived class. Okay, what access specifier defines? It defines the scope of members of base class into derived class. Okay, scope of members of, okay, what access specifier it will define? It will define the scope of members. Okay, scope of members of base class into derived class. C++ suppose the following access specifiers: private, protected, and public. Okay, three types of specifiers: private, protected, and public. So first, private specifier. So the scope of private members are restricted to its own class. Private members can't be accessed by the derived class or in main function. So first, private. What is private here? The scope of private members are restricted to its own class. Okay, so if you say class X and if you say public, then what happen if you say private? Class X private int x is equal to 10, so that is limited to only that class. In X class only its capacity, it cannot that value will not transfer to the next class, or it will not travel to the main function also. It will limited to that class only. That is the private. Okay, that's what we are saying. The scope of private member is limited to its own class. Okay, the scope of private is limited to its own class. It will not travel from one class to another class. It will not travel from one class to another class, or it will not travel from one class to main function also. It's okay, its access is limited to the one class only. Private members can't be accessed by the derived class or in main function. Okay, it cannot be accessed by the derived class or main function. Means if it is declared as a base class, its access is limited to base class only. That's why we have seen all the inheritances, but in inheritances we have never used private. Okay, have we used private here? No, always we wrote only public only. Okay, we wrote public. For access specifiers also we wrote public only. Second one, protected specifier. What is this protected specifier? The scope of protected members are restricted to its own class and derived class. Okay, now what is protected means, it will transfer the data. Okay, it will transfer the values, or it will transfer the function from its own class to the next class, that is derived class. Okay, so what is why we can use protected? If I use protected, so if I use protected, what happens? It will give the values to its next class. Okay, it will give the value to its next class also. That is, if I am giving, if I kept protected, see class A, I have taken class A. If I take protected int A, okay, class A if I taken, and protected if I taken, see class A I have taken, here protected A I have taken, so protected if I taken, then what happens here? Instead of public I have taken protected, and here int X I have taken. Okay, I have closed this one. Class B I have taken. Okay, class B, column public A, public A I have taken. Okay, int Y I have taken. So now what happens means, whatever the properties, whatever the protected, okay, in protected I have declared one variable, that is index. This index value will be available to B class. Okay, so the value of X will be available to only this B class. Okay, further it will not be available. Okay, means this X class will not go to this main function. Okay, we are declaring here void main function. If I declare here void main function, okay, so it will not transfer to this main function. Okay, here what I'm going to do, I'm going to create a B object. Okay, B object I'm going to, and B dot X is equal to 10, B dot Y is equal to 20, I'm saying. Okay, so what happens means, so if I use this protected X, if I use this protected X, it will transfer from X value to here only, but it will not travel to here. So for example, if I have taken protected there, so now if I want to create an object here, object of which class I want to create, class A object. So A class object I have created. After creating this A class object, if I say A dot X is equal to 10, okay, then what happens? This is not possible. Okay, this is wrong here. Okay, why it is wrong? Because protected variable cannot be defined in main function. It can transfer the value from base class to only derived class. Here I can give value for x. Okay, here I can declare x is equal to 10 using a function. In get function, enter the value for x, and x c in x I can give. Okay, I can enter the value for x in class B, but I cannot enter the value for x in void main function. It cannot transfer the value from, okay, from base class to main function. It can transfer a value from base class to derived class. Okay, from base class to derived class it is possible, but base class to main function it is not possible if I take it as a protected. So if I taken as a public, you all know this one, public. If I taken as public, it is possible. If I take it as public, the value will be available to derived class as well as it will be available to, now it is possible, it is available to main function also. If it is, now if I take it as private, now what happens? Now the value of x will not be transferred to class B only. If it is not possible to transfer to class B, it is not possible to transfer to void main function also. That's why we are not taking private here. If I take private and if I take public, so this value, whatever value is there, this int x value will not be transferred to derived class, or it will not be transferred to main function. Okay, that's why it is a private. Then how means I have to declare one more public function. This all we have seen in first, before learning this object oriented program. Here again I have to take a public, and then I have to declare a get function. In get function I have to give a x value function. Okay, then that get function will be transferred. Means if I taken it as a private, so the value will be limited to this whole class. Okay, the value will be limited to this class only. It will not transfer the value to this class. If I taken it as a protected, it can transfer the value protected. If I taken as protected, the value will be transferred from the base class to derived class. Okay, yeah, the value will be transferred from the base class to derived class, but it will not transfer to main function. Okay, it will not transfer to main function, so the value will be available for the this derived class only. Okay, the protected, if I taken, it will be available to derived class, but it will not be available to main function. If I taken as public, everywhere it is access. If I taken as public, okay, the whole class will be available to main function also. So that's why in inheritance case, in every concept we have taken as, okay, in everywhere we have taken it as public. Okay, so see, class of public, protected and private inheritance, class base, public index, protected int y, private int z, class public derived. Okay, so class public derived, public base. Okay, this is a base class, this is a derived class. So here derived class name, actually derived class name, and here public derived. Okay, here derived class name, and then public base class. Okay, public base class name. If here it is a public, then only it will the, okay, this will be access. X is public, y is protected, but z is a not accessible from public derived. See, private z we said, so this value will not, okay, this value will not be available to here in derived class, it will not be. Next, okay, so next if it is protected, okay, so class derived, here protected I have taken protected base. If it is protected, in the place here protected, if I say, then x is protected, y is protected. What is x is protected, y is protected? X and y value will be, base class value will be available to derived class, but z is not accessible from protected derived. Okay, from protected derived, so z, again z is not available to this class also. If it is public, it is z is also not accessible. X is public, y will be protected, because here y we have say protected, so y will become a protected, z is not accessible. If another class protected base is there, okay, then x is protected, y is protected, z is not accessible. If class private, okay, if I declare it as a private, then what happens? Okay, class private derived, then class derived class has a private base. X is private, Y is private, Z is not accessible for private derived. If it is private, X will become as a private, Y is private, Z is not accessible. Z is not accessible obviously, and X is become private. If X and Y are private, these are not available to main functions. If it is a protected, it will not available to main function, but derived class it will be available. Means for this class, this X and Y values will be available. Okay, but here these values will not be available to main function. In the above example, we observe the following. See, this one we can clearly we can understand through graph. Okay, derived classes and base class. If base class is private, okay, if base class is private, in derived class, if it is private mode, not inherited. Okay, base class, if it is base class private, okay, if base class is a private, then derived class is private mode, then it is not inherited. If base class is protected, if base class is protected and derived class is private, then the value will become a private only. If base class is public, derived class is private, then it will become a private only. The derived class will become a private, because derived class is private means it will become private only, means it will not be available to main functions. This derived class will be not be available to main functions. Okay, this all derived classes will not be available to main functions, because derived class is in private mode. Base classes are private, protected and public. If base classes are private, protected and public, derived classes are private mode only. First one not inherited, second and third are private, means it is not available to main functions. Not inherited means it will not come to main. Both are in base class it is private and derived class it is private, means not inherited, means it is not possible only. Okay, inheritance only not possible, means we should not write such type of program. Only writing program is waste, because it is not accessible. If it is not accessible, writing program is waste. Okay na, బేస్ క్లాస్ లో ప్రైవేట్ ఉండి derived క్లాస్ లో ప్రైవేట్ ఉందంటే అది అలాంటి ప్రోగ్రామ్ రాయకూడదు. బేస్ క్లాస్ లో ప్రైవేట్ ఉండి derived క్లాస్ లో ప్రైవేట్ ఉంటే అలాంటి ప్రోగ్రామే రాయకూడదు. బేస్ క్లాస్ లో ప్రొటెక్టెడ్ ఉండి derived క్లాస్ లో ప్రైవేట్ ఉందనుకో, ఆ ప్రోగ్రామ్ అనేది ప్రైవేట్ అయిపోతుంది, అంటే మెయిన్ ఫంక్షన్ కి రాదు. బేస్ క్లాస్‌లో పబ్లిక్ ఉండి, డిరైవ్డ్ క్లాస్‌లో ప్రైవేట్ ఉందనుకో, ఆ ప్రోగ్రామ్ ప్రైవేట్ అయిపోతది. ఓకేనా? అంటే మెయిన్ ఫంక్షన్‌కి రాదు. ఇదొక్కటి గుర్తుపెట్టుకుంటే సరిపోతుంది. నెక్స్ట్ ఈస్ బేస్ క్లాస్, డిరైవ్డ్ క్లాస్, ప్రొటెక్టెడ్ మోడ్. సో, ఇన్ డిరైవ్డ్ క్లాస్ అగైన్ ఇఫ్ ఇట్ ఈస్ ప్రొటెక్టెడ్ మోడ్ వి విల్ సీ. బేస్ క్లాస్ ప్రైవేట్, డిరైవ్డ్ క్లాస్ ప్రొటెక్టెడ్ మీన్స్ ఇట్ ఈస్ నాట్ ఇన్హెరిటెడ్. ప్రైవేట్ ఇన్ బేస్ క్లాస్‌లో ప్రైవేట్ ఉంటే ఇంకా అది ఏ క్లాస్‌లో కూడా అది ఇన్హెరిట్ కాదు. Okay, if base class is private and derived class are protected mode, it is not inherited. If base class is private, derived class is public mode ఉన్నా కానీ అది inherit కాదు. Okay, derived class is protected mode, it is not inherited. If it is protected, derived class will become a protected. Okay, if base class is public and derived class is protected mode, it will become a protected. Protected means what? It will be available to derived class only, but it will not be available to main function. Main function దాకా వెళ్ళదు, ఓన్లీ ప్రొటెక్టెడ్ ఫంక్షన్ కే, ప్రొటెక్టెడ్ అంటే డిరైవ్డ్ క్లాస్ వరకే అవైలబుల్ ఉంటుంది అనమాట. ఓకేనా, డిరైవ్డ్ క్లాస్ వరకే అవైలబుల్ ఉంటుంది. ఓకే, ఇది ఎలా అంటే త్రీ థింగ్స్ are there: private, protected, public. How we can understand means public is a known secret. Okay, public means it is a known secret, we can reveal to everyone. Protected means it is a secret which should be told to our own family. Okay, friends కి వాళ్ళకే చెప్తాం. ఓకే, ప్రొటెక్టెడ్ మీన్స్ వాట్? ఓన్లీ డిరైవ్డ్ క్లాస్ ఓన్లీ, మీన్స్ ఓన్లీ నోన్ ఫ్రెండ్స్, ఓన్లీ ఫ్రెండ్స్కి, ఓన్లీ ఫ్యామిలీకి, అట్లానే అందరికీ చెప్పం. ఓన్లీ ఫ్రెండ్స్ అండ్ ఫ్యామిలీస్, క్లోజ్ రిలేటివ్స్ అండ్ క్లోజ్ ఫ్రెండ్స్ ఓన్లీ విల్ టేక్. Whereas private, it is totally private, we are not going to reveal it to anyone. Okay, it will be secret to our own self only. ఎవరికి చెప్పం, that secret will be with us only. That is private. Okay, so if base class is private and derived class is public mode, not inherited. If base class is protected, derived class is public mode, protected. If base class is public, derived class is also public mode, it will become a public. Okay, this is a access specifier. If you remember this table, that is enough. This is also very important question. Next very important question, what is a polymorphism? Very important question. what is polymorphism. Okay, this ends a access specifiers. Next is polymorphism. So polymorphism, what do you mean by polymorphism? Means poly means many, morphism means forms. So many forms, polymorphism. Poly means many, morphism means forms. So if I declare many functions with the same name, then it becomes a polymorphism. Okay, here in this example, we'll say polymorphism is a technique in which various forms of a single function can be defined and shared by various objects to perform the operation. Okay, so in real time, now we are writing a program. If we are writing a program, in that program, we are having a 10 functions, 10 member functions we are defining. If we are defining 10 member functions, all the 10 member functions should be different. Yes or no? All the 10 member functions should be different. So in real time, how many member functions will be there? Now, if you're creating any application, if you're creating any application for any software company, then you are going to create some hundreds of function. If hundreds of function you are creating, all the hundreds of function names should be different. Then how much difficult it is? From where we can get all that 100 names for 100 functions? It is very much difficult. So here, this polymorphism function topic got. What is polymorphism means? You can use the same function name. If you use the same function name, again, what error we are getting means the computer is getting confused to call which function. Now, Ramesh, two members are there. If I call Ramesh, what happens? Both Ramesh will look to us. Yes or no? So in the same way, polymorphism means if I am having two function names, two functions with the same name, both will be called. Both will be called means the computer cannot call both because it will display an error. It will say that two functions are there. So which function I need to call? I don't know. It will say it as a error. So here, this polymorphism concept will give us such, it will avoid such type of error, and we can able to call the same function name. We can able to write a function, same function name number of times. Okay, how we will see. Polymorphism means only that one. Polymorphism is a technique in which various forms of a single function can be defined and shared by various objects to perform the operation. Okay, various forms of a single function. Various forms of a single function means what? So I can define a one single function. I can call number of times. Polymorphism. Runtime is virtual function. Compile time is function overloading. Okay, so polymorphism are the two types of techniques are there in this. Runtime polymorphism we call, compile time polymorphism. Runtime polymorphism example is virtual function. That is multipath example. Multipath inheritance is there. That one example. And compile time polymorphism means function overloading. This function overloading we are having in a second unit. Okay, this is also very important question. What is function overloading, they will ask. So I left there, that's why to cover here I left the topic there. So in compile time, function overloading is there. If I write this function overloading program there also, that is there they will ask the question, what is function overloading, give an example for function overloading, they will ask. Okay, in second unit. Here if they are going out to ask in third unit, they will ask what is polymorphism, give an example for polymorphism, they will say. Then you can write any one program. Either you can write a runtime program or you can write a compile time program. Okay, runtime program means virtual function program you have to write. Compile time program means function overloading you have to write. Both will come under polymorphism. Okay, so virtual function is an example for multipath inheritance. Function overloading is an example for compile time. Okay, so function overloading. What is function overloading? First we'll see. Polymorphism means function overloading. Okay, what is polymorphism? Writing the same function name, okay, two or more times. Defining the same function name two or more times is nothing but it is called polymorphism. Simple definition. What is polymorphism? Defining the same function name two or more times is called function overloading. So here in function overloading, we'll see the definition. The derived class can have the same function name as base class member function. In base class, we are defining some function. The same function name we will have in derived class also. Okay, so this is not possible. Okay, this is not possible. That's why we have wrote display function, we have wrote disp function, we have wrote di function, we have wrote d function in inheritance program. So to avoid this ambiguity, we are writing this polymorphism. So now in base class, if I'm writing display function, same display function I can write in derived class also. Base class I can write display, in derived class also I can write display. So that is possible using function overloading. You will see here. Okay, an object of a derived class invokes the member of the derived class even if the same function is present in the base class. Okay, see. Program to overload the member function. Class B public void show functions. Class D public. Okay, see. This is function overloading. Function overloading means writing the same function name in both base class and derived class. We know that class B is a base class. Okay. Class B is a base class. Okay. So in base class, what function we are having? Show function. Void show function we are having. Then class D, derived class. Class D is a derived class. Okay. Here we are having base class and class D is a derived class. Okay. We are having base class and class D as a derived class. Okay. Base class we are having and derived class we are having. Now see, base class is having a function name called void show function. Void show member function it is having, and derived class is also having a void show function. Same function name we are having. Void show function, void show function. See. So how it is accessible? We'll see. Okay, base class and derived class. Yeah. So void main function, clear screen. We are creating a base class object as well as derived class object also we are creating. Okay, B base class object, D derived class object. B dot show function. If I say B dot show function, okay, it will display this base class function. If I say D dot show function, it will display derived class function. Because now class D inherit the properties of class B. Through D also I can display this base class function. Okay, understood. Using D is a derived class function. Derived class function means what? Whatever the property of base class will be there, that will be available to D class. Now what is the property? Show function is there. Here it is having show function, here also it is show function. Now using D class, if I want to access this show function, how I can access? See, okay, how I can access means D dot B, B is a base class. Okay, base class name D dot capital B scope resolution operator show function. If I use scope resolution operator and B show function, it will display base class. Okay, it will display base class function. If I use scope resolution, it will display base class function. If I use normally D dot show function, it will display derived class function. Understood? Directly I can create a base class and derived class objects and I can display it. From the derived class I want to display the base class means I can use scope resolution operator. Okay, scope resolution operator and I can display it. Okay, see, if I use scope resolution operator here, what happens? The control will go from here to here. The control go from here to here. It will go to base class show function. It will go. Why? Because I have used scope resolution operator. Because I have used scope resolution operator, okay, it will go to first base class. Clear? This is function overloading. We'll see through example. Okay, I hope you all can see my screen. Open. What example is this one? Function overloading. Yeah. So hash include iostream.h, hash include conio.h, class B, base class, public void show function. In void show function, what output I am having? Cout in base class function. Again, I have closed class B. Again, I have used class D function, public B. Okay. So base class and derived class. So derived class is D. It inherits the properties of base class. Okay. So it inherits the properties of base class means what? Okay. It inherits the properties of base class means it inherits the properties of base class means the show function will be available to D class, derived class. Okay, base class is derived class. See, in derived class public again same function name void show, same function name void show function in derived class. Void when clear skin, B object. Okay, D object, B dot show function I have used, D dot show function I have used. If I use B dot show function, it will display base class object, base class output. If I use the D dot show function, it will display derived class output. But if I use D dot B scope resolution operator show function, it will display base class output. It will display means using derived class object. Using derived class object, I can display base class output. Okay, using derived class object, derived class object, I can display base class object. Okay, using derived class object, I can display base class object. Okay, shall we see? Undefined symbol void. Okay, some errors are there here. I haven't seen these errors here. Okay, save, control F9. Yes, in base class function, in derived class function, in base class function. This one I have first output I have first output it displayed using base class object only. Base class object I have created, base class object I have displayed. Second, derived class object I have displayed, derived class output it I have defined. Third one, using derived class object I have displayed base class output. Using derived class object I displayed base class output. Okay, so this is function overloading. Clear? I hope you all have understood that one. Next, go into virtual functions. Okay, a virtual function of base class must be redefined in the derived class. The programmer can define a virtual function in the base class and can use the same function name in any derived class, even if the number and type of arguments are matching. So what is virtual function means? Virtual function of base class must be redefined in the derived class. Same for like function overloading only. Okay, like function overloading only. So we are defining here. What is function overloading? Writing the same function name number of times is called as function overloading. Writing the same function name in both base and derived class is called as a function overloading. I can give the above example also, function overloading example. Second type of example is virtual function. These both are example for polymorphism. Polymorphism means function overloading as well as virtual function. So virtual function of base class must be redefined in the derived class. The programmer can define a virtual function in a base class and can use the same function name in any derived class, even if the number and type of arguments are matching. Okay, the programmer can define a virtual function in a base class and can use the same function name in any derived class. In base class, whatever function you are writing, same function name I can use in derived class. If it is having number of arguments, also the same function name I can use. Like for example, void show, okay, int show int a comma int b is there. This is one member function, int show int a comma int b. This member function is in base class. The same function I can derive in derived class also. Int show int a comma int b, same name, int show int a comma int b, int show int a comma int b in both base and derived class. But what it should be different, we can use the virtual keyword. Virtual keyword I can use, okay, in front of derived class. In derived class I have to mention a virtual keyword, then it will work. If I don't use virtual, it will not work. The rules of virtual function are: the virtual function should not be static and must be member of a class. Okay, virtual function cannot be a static, and static keyword we should not use for that function. A virtual function may be declared as friend for another class. Okay, a virtual function can be declared as a friend keyword I can use. Constructor cannot be declared as virtual, but destructors can be declared as virtual. Okay, one more point is, constructors cannot be defined as a virtual function, but destructors can be defined as a virtual function. Okay, constructors, for constructors we cannot use a virtual function. Virtual function must be defined in public section of the class only. It is also possible to define virtual function outside the class. In such case, the declaration is done inside the class and definition is done outside the class. So virtual function must be defined in public section of class only. Okay, it is also possible to define virtual function outside the class. It is possible, but declaration is should be done inside. Definition should be run outside the class. Like we have wrote using scope resolution operator, like that. It is also possible to return a value from virtual function like other functions. Okay, so virtual function can also return value. Okay, it can also return value to the other functions. The prototype of virtual function in base and derived class should exactly the same. In case of mismatch, the compiler neglects the virtual function mechanism and treats them as a overloaded function. Okay, so if you don't write virtual keyword and you're writing a program, the compiler will avoid it and it will think it as a overloaded function. It will think. Okay, see the program to declare virtual function: hash include iostream.h, hash include conio.h, class first, int b, public. First is the constructor here. We are using constructor here. Constructor b is equal to 10. Virtual void display. See, virtual keyword we use. Virtual void display, we are using this one in a base class. Virtual keyword we are using in a base class. Virtual void display, cout b is equal to b. We are displaying a value. We are giving a value through constructor. We are displaying it through virtual. Okay, virtual function we are writing. Virtual keyword, virtual void display function. We are writing cout b is equal to b. B value we are displaying in a virtual void display. Class second, public first. Okay, class second, public first. So class second is a derived class. It inherits the properties of both. Means this first constructor will be available and this void display will also be available. Int d, we are declaring one more value here in class second. Int d, public second d is equal to 20, using constructor. Void display, see, we are using the same function name. In base class we are having void display. In derived class also we are having a void display, but in base class we are writing virtual keyword, but in derived class we are not writing virtual keyword. Only once we wrote virtual keyword, that is enough. In derived class we are writing a void display. So void main function, first f comma pointer p is equal to ampersand f. Okay, pointer p means what? It will display the, okay, address of the, it will the pointers concept, right? So p means it will show the address of the first object. So whatever the address of first object will be there, it will be stored here. And p arrow display, okay, if you are using a, okay, pointers, we can display it you through arrow operator also. Arrow operator or dot operator, you can use both. instead of dot operator, we are using arrow operator here. P dot display instead of p dot display, pre arrow display we are using p arrow display. Okay, next again p is equal to ampersand s, second class. Okay, address it will be stored using that one p arrow display. Now second also it will be displaying. See, okay, control C, control V, yes. We are having two classes, class first and class second. Okay, class X, this is class X, this is class Y. Okay, so class X will inherit the properties of class Y. Now, if I create an object for first class, sorry, class first and class second I have taken class names. Class first, class second. I've taken two classes, class first and class second. Class first will inherit the class second will inherit the properties of class first. Class first is a base class. Class first is a base class. Class second is a derived class. Okay. Array. Oh shit. Okay, so class first is a base class and class second is a derived class. So all the first class, what all functions we are having here? So what all functions we are having means virtual void display. Okay, virtual display and one constructor it is there. So what is the constructor name? First constructor is there. Okay, that one. In second we are having void display function. Okay, void display function. So see, so if you're using virtual concept, we have to use a pointers concept as well. So what is pointers here? If I say first F, okay, first F object we are creating. Okay, so we are creating a this object. Okay, say. So first we are creating an object. First, okay, F. So first class object F is created. So after creating this object, we are creating a pointer P. So what is pointer P? What is pointer P means? It will store the address of the address of the another object. Okay, whenever we declare a pointer, so pointer p, okay, if I say asterisk and if I say, okay, so if I say asterisk, if I say asterisk and if I give some value, it will become a pointer. What pointer will do? It will store the address of another object. So p first comma f and pointer p I said. Now first f will have some value. Okay, for what first f will have, it will have some address value 4345. So next I'm giving, I have created pointer p. If I create a pointer p, it will not store a value, whereas object first f will place an classes in it. Okay, it will place a class. What class it will display? It will have, okay, it will display the in first what all we are having. We are having virtual void display function. We are having virtual void display in it. Virtual void display is there, and one more, it is having a first constructor, it is there. Okay, it is having first constructor and virtual void display. Okay, both it is having one member function, it is having one constructor, it is having. Okay, if I say first f, if I create first f object here, what it will happen, it will create, okay, it will create a memory space. Okay, and the memory, it will create a memory space in a hard disk. For this it will having one memory address, that is 4345. If we consider 4345 as address, it will have, it will reserve a memory space for it. If we create a object for it. Now we are creating a pointer also. Pointer p, what it will do, it will store the address of another object. Okay, pointer p means it will store the address of another object. It cannot store any member function or it cannot store any constructor. So in next case, what we are doing, p is equal to ampersand f, we are saying. Now if I say p is equal to ampersand f, what is the address of this first f? 4345. So this 4345 will be stored here. 4345 will be stored. Now if I say 4345, now what happens here? Now what happens means, whatever the value of first object is there, whatever the value of first, okay, first f object is there, that all will be available to pointer p also. ఓకే, అర్థమవుతుందా? పాయింటర్ పి అని పెడితే ఏమవుతుందంటే, ఇట్ కెన్ స్టోర్ ద అడ్రస్ ఆఫ్ అనదర్ ఆబ్జెక్ట్. ఓకే, వాట్ ఈస్ ద అడ్రస్ ఆఫ్ అనదర్ ఆబ్జెక్ట్? 4345 is an address. So this 4345 will be stored in pointer p. So if it can store the address of another object, okay, so what happens means, ఇప్పుడు అప్పుడు ఏమవుతుంది, అప్పుడు ఏమవుతుంది అంటే పాయింటర్ పి కనుక మనం డిస్ప్లే చేస్తే, దాంట్లో అంటే పాయింటర్ పి యూజ్ చేసుకొని కూడా మనం ఫస్ట్ క్లాస్లో ఏముందో అది డిస్ప్లే చేయొచ్చు. ఫస్ట్ క్లాస్లో ఏముంది, మెంబర్ ఫంక్షన్ ఉంది, వర్చువల్ వైడ్ డిస్ప్లే ఫంక్షన్ ఉంది, ఫస్ట్ కన్స్ట్రక్టర్ ఉంది. అంటే ఆ వాల్యూస్ అనేది డిస్ప్లే చేయొచ్చు, అంటే ఆ ఫంక్షన్ని మనం కాల్ చేయొచ్చు పాయింటర్ పి. ఓకే, సో సి, ఇఫ్ ఐ సే పాయింటర్ పి అండ్ ఇఫ్ ఐ సే పి arrow display, if I say p arrow display, what happens? P arrow display, if I say, what happens means, using point now p arrow display means using p I can display first class member function value. I can display first class virtual void display function I can call. Okay, I can call this. Okay, I can call first class member function. Okay, see, using p I can call, using p okay, using p what I can do, oh sorry, wait. Using p, what I can do, I can call this virtual void display function using p. Okay, so now I'm not using f dot virtual void display function. I'm not using, what I'm using, p dot display I'm using. F dot display I can use, but if I use f dot display, it will become a ambiguity. That's why what I'm doing, I'm creating a pointer. Using this pointer p, I'm calling p dot display. If I say p dot display, it will display this function. Okay, similarly, same as it is here, uh, after displaying this virtual void display function, this value, again what I have to do, I have to display second derived class display function also I have to create. Now after displaying this value of void display function, again this pointer is pointing to this first only. Now I want it to point it to second derived class. I want to point it. Then what I will do, again in second case, what I will do means I will use p is equal to ampersand s. I will use, if I say p is equal to ampersand s object is there. Okay, here I didn't wrote actually. Sorry. Here I have to write here. I have to write here second s. Second s. Second s is what? Second s. Okay, second s is what? Derived class object. Okay, class second is there. So I am declaring a derived class object. Second s I have declared. After declaring the second s, I will write p is equal to ampersand s. If I say p is equal to ampersand s, what happens means now what happens? Now what happens means no 1 minute. What it will happen means, okay, it will remove this pointer here. After removing this pointer here, okay, second s we have created object for second class, that is derived class object we have created. Second s, this is second s is an object and its address is some, we'll consider 4, okay, 5 6 2 4 5 6 2 if I consider. Then what happens means, now if I say p equal to ampersand s, now second class, okay, address it will store in this one. Okay, what is the second class address? 4, okay, 4 5 6 2. Okay, 4562 will be stored in this one. Now if 4562 will be stored in this one, means what? Now this pointer will be pointing to this second class. Okay, pointer will be pointing to this second class, that is derived class. The pointer will be pointing to derived class. Okay, what is there in this derived class? It is having, what is there in this? It is having one constructor by name second. Second constructor is there, and one more, what it is there? Display function, void display function. So now it will display this one, means using single pointer I will display the contents of first class, as well as I will display the contents of second class. I will display the contents of base class, as well as I will display the contents of second class. First what that's why what I have to what I have did means, first I have created the object. First f I have created, it will create one object first f, and comma pointer p I said. So pointer p also it will create, that means okay, it will create a memory space, but it will not store any value until you write this one, until uh, until you write p is equal to ampersand f. Until you don't give this value, okay, until you don't display this value, it is not going to show it. Okay, until you p is equal to ampersand f, if you don't write, it is not going to show it. If you say p is equal to ampersand f, what it is happening here? Okay, what it is happening here, if you say p is equal to ampersand f means it will create, okay, so it will create, what it will create, it will reserve a memory space, but it will not store any value. It will store the address of another objects. Okay, another object address it will store. So what address it is showing? P is equal to ampersand f means it will store this first f address 4345, it will store initially. Then after storing this address, what we have done, p arrow display we have done. Then it will display virtual void display, and first it will display virtual void display. What it is there? Value of b is there. Value of b, where we have given in first constructor, we have given b is equal to 10, and it will display this one. Means using pointer you will display. Okay, so see, I am explaining it in Telugu once again. సో ఇప్పుడు ఏమవుతుందంటే పాయింటర్ పి ఒకటి తీసుకున్నాము. ఫస్ట్ క్లాస్ ఆబ్జెక్ట్ ఒకటి తీసుకున్నాం. ఇప్పుడు ఫస్ట్ క్లాస్ ఆబ్జెక్ట్ క్రియేట్ అయిపోయిన తర్వాత మనం పాయింటర్ పి అంటాం. పాయింటర్ పి ఏం చేస్తుంది? అది ఒక అడ్రస్, ఓకే, ఒక అడ్రస్ అనేది స్టోర్ చేసుకుంటుంది. దేని అడ్రస్ స్టోర్ చేసుకుంటుంది? ఫస్ట్ క్లాస్ అనే ఆబ్జెక్ట్, ఫస్ట్ క్లాస్ ఆబ్జెక్ట్ ఉంది కదా, ఫస్ట్ క్లాస్ ఆబ్జెక్ట్ ఒక అడ్రస్ దాంట్లో స్టోర్ చేసుకుంటుంది. ఫస్ట్ క్లాస్ ఆబ్జెక్ట్ అడ్రస్ ఏంటిది? 4345 అనుకున్నాం అనుకో. ఆ 4345 వచ్చేసి పాయింటర్ పిలో స్టోర్ అవుతుంది. స్టోర్ అయిన తర్వాత మనం పి యారో డిస్ప్లే అంటున్నాం. పి యారో డిస్ప్లే అనగానే ఏమవుతుందంటే వర్చువల్ వాయిడ్ డిస్ప్లే ఫంక్షన్ అనేది వాల్యూ ఏముందో అది డిస్ప్లే చేస్తుంది. దాంట్లో అవుట్పుట్ ఏముంది? బి ఈజ్ ఈక్వల్ టు బి వాల్యూ ఉంది. పి వాల్యూ ఎక్కడ ఇచ్చాం మనము? కన్స్ట్రక్టర్లో ఇచ్చాం. ఫస్ట్ అనే కన్స్ట్రక్టర్లో బి ఈజ్ ఈక్వల్ 10 అన్నాము. వర్చువల్ వాయిడ్ డిస్ప్లే అనగానే అది డిస్ప్లే చేస్తుంది. డిస్ప్లే అయిపోగానే మనం ఏం చేస్తున్నామంటే దాని యారో తీసేస్తున్నాం. దాని యారో తీసేసి సెకండ్ క్లాస్‌కి మనం రిఫర్ చేస్తున్నాం. సెకండ్ క్లాస్‌కి రిఫర్ చేయాలంటే ఏం చేయాలి? సెకండ్ ఆబ్జెక్ట్ క్రియేట్ చేయాలి. సెకండ్ ఎస్ అని క్రియేట్ చేసిన తర్వాత పి ఈజ్ ఈక్వల్ టు యాంపర్సెంట్ ఎస్ అని పెట్టాలి. పి ఈజ్ ఈక్వల్ టు యాంపర్సెంట్ అని పెడితే ఏమైతుందంటే ఆ యారో ఫస్ట్ నుంచి తీసి సెకండ్‌కెళ్తుంది. సెకండ్‌కెళ్ళిన తర్వాత అక్కడ మనం ఏం చేస్తున్నామంటే సెకండ్‌ది డిస్ప్లే చేస్తున్నాం. సెకండ్ అనే కన్స్ట్రక్టర్‌ని డిస్ప్లే చేస్తున్నాం. ఇంకా డిస్ప్లే అనే దాన్ని మనం డిస్ప్లే చేస్తున్నాం. ఎందుకు పాయింటర్ ఒక్క దగ్గర తీసి ఇంకో దగ్గర పెడుతున్నాం అంటే సేమ్ నేమ్ ఉన్నాయి కాబట్టి ఫస్ట్ వర్చువల్ వైడ్ డిస్ప్లేకి చూపిస్తున్నాము. తర్వాత దాని యారో తీసి మళ్ళా సెకండ్ దానికి పెడుతున్నాం. ఓకే, అది దట్ ఈస్ ద వర్చువల్ ఫంక్షన్. ఓకే, అండర్స్టూడ్. Take the snapshot of this one. Okay, take snapshot of this one. Okay, so if you want, I will send this snapshot to you also. Okay, so while I will send this, so while sending a notes, I will send this one too. Okay, I will send notes also, no? So I will send this diagrammatical representation so you can understand it more clearly. Excuse. I sent it through graphical representation. You can easily understand this. Okay. So what you do means you see this diagram and listen, then you can clearly understand. Okay, what is virtual? So this is very, very important. That's why I'm sending that one, virtual functions. Okay, this completes the topic virtual. Next is dynamic memory allocation. Okay. Okay, so we haven't seen this example program, right? We'll see example also. 1 minute. Yeah. So this is virtual example, virtual function example. Hash include iostream.h, hash include conio.h, class first, int b, public. Okay. First constructor, we're giving value b is equal to 10. Okay, int b is a private, public. In public we are saying first is a constructor, so I can give a value here, b is equal to 10. Next, virtual void display. This is the virtual function I'm defining, virtual void display. So in virtual void display, what output I'm writing, cout b is equal to b. Next, class second, this is a derived class. Public first, so public properties all will be okay inherited by second class, derived class. Int d I'm taking here public second constructor, d is equal to 20. Then void display functions, the same function name I'm using. Here I'm using virtual keyword. Here I'm not using any virtual keyword. Directly I'm using virtual void display. Okay, virtual sorry, void display I'm using here. Virtual void display I'm using here. Here I'm using void display. Cout void main function clear screen. First f object I'm creating. Okay, first class object I'm creating. Then I'm creating a pointer p. After creating a pointer p is equal to ampersand f I'm saying, and p arrow display I'm using. P arrow display means it will display the first class object. It will display using p pointer. I'm displaying the object. Next, second object I have created. P is equal to ampersand is p arrow display I'm saying. Then it will display the second class object. Same thing it is doing. Yeah, b is equal to 10, d equal to 20. B is equal to 10 is base class, d is equal to 20 is a derived class. Okay, base class value and derived class value. First the pointer will take b is equal to 10 value. Later again the same p is taking a derived class value, d is equal to 20. Means one pointer, it is pointing to both b is equal to 10 and d equal to 20. B is equal to 10 is in first class, d is equal to 20 is in second class. First the pointer will point to base class. Next again pointer will pointing to derived class. To point a pointer to the base class, what we are using, p is equal to ampersand f we are using. Okay, p is equal to ampersand f. Now if I use p is equal to ampersand s, it will show it to derived class. Okay, so this ends. Next, dynamic memory allocation. This is also very important question, dynamic memory allocation. Okay, very important questions, these all things. So the same dynamic memory allocation is also same like that only. So what we'll see, dynamic memory allocation means creating a memory at runtime. For example, when we declare an array, we must provide the size of array in outsource code to allocate memory at compile time. Okay, so when we declare an array, okay, how we are going to declare an array? Okay, if we declare an array, okay, so what we are going to do means we must provide the size of array. Okay, while we are declaring an array, we must provide a size of an array. But if we need to allocate a memory at runtime, we must use a new operator. Okay, so if we want to allocate a memory at runtime, we must use a new operator followed by data type. If we need to allocate the memory for more than one element, we must provide the total number of elements required in square brackets. Yes or no? This one you know. Okay, this is like array only. If we need to allocate a memory for more than one element, we must provide a total number of elements required in square bracket. If I say, okay, char int of, sorry. Mm, okay, so pointer equal to new data type, pointer equal to new data type size. So what I'm saying means new data type size, pointer equal to new integer, size is 10 20 you are giving, so it will become another data type. So what I'm saying means here, if you need to allocate a memory for one or more than one element, what you are going to do, you are going to display here as 10. If I say 10, it will allocate memory 10 places. Okay, 1 2 3 4 5 up to 10 it will allocate. That is okay, we know. If we want to declare, if we want to declare it as a one only, then what we are going to do, we are going to declare, okay, char c we are writing, then it will take it as one memory space only. Okay, so if we declare char c, it will take one only. If I say char c in square bracket 10, we can have 10 values. Okay, 10 characters I can have. That is what we are saying, like array only. New operator. What is new operator? Means the new operator dynamically allocates memory at runtime with, within the heap and returns the address of the space allocated. So what new operator will do means new is a keyword actually here. So the what new operator will do means the new operator will dynamically allocate a memory at runtime within the heap. What is heap? Heap is a memory space. Okay, within the heap, it will allocate a memory at runtime. Now at runtime means what? While the program is running, it will allocate the okay, memory for it. Okay, syntax is pointer equal to new data type. It allocate the memory for one element. If I say pointer equal new data type, pointer equal to only new data type, if I say, it will allocate memory for only one element, it will allocate. It will allocate memory for one element. Pointer equal new data type means pointer is equal to new data type means int. Pointer equal to new int, if I say, it will allocate memory for only one element. If I say pointer equal new data type size, if I say, it will allocate memory for a fixed number of elements, not one element, fixed number of elements I can have. Okay, this is the simple syntax of a okay, operator. Okay, new operator. If I say pointer equal to new data type size, so whatever size I can choose. If I choose 10, it will allocate the memory space for 10 elements. If I say 20, it will allocate the memory space for 20 elements. If I don't say anything, it will allocate the memory for only one element. Okay, that is new operator. Delete operator. The delete operator is used to deallocate the memory created by the new operator. So whatever the new operator created that memory, to delete that one, we can use a delete operator. So the syntax is a delete pointer. If I say delete pointer, it will deallocate the memory for one element. If I create a new element using new data type, pointer equal new data type, to delete this one, I can use delete ptr. If I say delete ptr, it will delete. Or if I want to delete square bracket pointer, deallocate the memory for array. So whatever you have defined here, pointer equal new data type size, to delete this one, I can use delete. Okay, in square brackets, I can use pointer, deallocate the memory for an array. Okay, we can write the example program to create a dynamic memory allocation using a new and delete operators. Hash include iostream.h, conio.h, class data, index y. Okay, public data, we are using a constructor. Okay, data constructor, I'm using cout constructor. X is equal to 10, y is equal to 50. Okay, I'm giving values for x and y. And destructor also I'm using destructor data, cout destructor, y display, cout x equal to x, y equal to y. Void main, clear screen, this is data, d is equal to new data, d arrow display, d delete d. After declaring declaration of object pointer, dynamic object, we're deleting the dynamic object. Okay, so you will see this one. Okay, this is dynamic memory allocation. See, hash and stream.h, class data, int x comma y, public data constructor, we're giving x equal 10, y is equal 20, destructor data, it will destroy. Okay, it will destroy the destructor, it will destroy the values x equal 10, y equal 50, it will delete. Okay, void display, cout x equal to x, y equal to y. Void main function, clear skin, data pointer d, declaration of object pointer. Okay, d is equal to new data. If I say d is equal to new data, okay, object is created dynamically. Okay, so data pointer d means what it is happening. Okay, data pointer d means it will create an object. Okay, it will create an pointer d, which will store the address of another, means it will store the address of data object. Okay, d is equal to, okay, new data, we are saying d is equal to new data means how much we are selecting the data, that much space only it will available. Now d arrow display. Okay, it will display, then delete it. Okay, simple, I can show this one. See, in constructor x is equal to 10, y equal to 50. Constructor, okay, in constructor it has given values x equal to 10, y equal to 50. Destructor destroyed the value x equal to 10, y equal to 50. Now 10 and 50 is deleted. After destructor will execute, the values of constructor will be deleted. Now x is not having any 10 and y equal to 50 is not having. Initially while displaying it is having the values x equal to 10, y equal to 50. After displaying destructor, the values is not there. Okay, again if you execute, again the constructor will create the values x equal to 10, y equal to 50. Again destructor will delete the values. Okay, this is same as previous example only, virtual function. No need to confuse. Data pointer d, we are saying a pointer will be created, okay, with the name d. It will store the address of another object. So what address it will store here? The address of data. Okay, the address of d only. Okay, what is the address of d? D equal to new data, we are saying. D equal to new data means, okay, dynamic object we have created. Okay, so it will store the address of d. Okay, so here we are using only one class data. Okay, so class data we are only we are creating. Pointed means it will create an object. Okay, instead of creating a instead of creating a direct object, we're creating a pointer object. Using this pointer object, we are creating a how much space we require. That much space only created. Okay, how much space we create for this constructor and destructor? Only that much space only it is created. Okay, d equal to new data, d arrow display. Okay, so new data means the constructor will be called automatically, d arrow display. So whenever you say delete d, the destructor will be executed. It will delete the object. Okay. Yeah. Sorry. So what do you mean by next is streams? So streams are also last important. Okay. So if you read perfectly 4 questions, then you can write in this unit. Streams is nothing but the flow of data. In object-oriented programming, the streams are controlled using the class. The operation with the files are mainly two types. They are read and write. Okay, so the operations of the files are mainly read and write. The iOS class is a base class. All other classes are derived from iOS classes. Okay, these classes contain several member functions that perform input and output operation. See, we are writing hash include iostream.h. So if you are writing a hash include iostream.h, here iOS is a base class and derived classes are iStream and OStream. Okay, from iStream and OStream we got StreamBuff. This is a derived class. StreamBuff is also a derived class. So here iOS is a base class. This is iostream.h. iostream.h file is there now. We are defining about this iostream.h header file. In this header file, how it is represented, we are showing here. The iStream and OStream classes control input and output functions. iStream and OStream will control input and output functions. Okay, so through iStream we got scene. Through OStream we got cout. Okay, iStream we got scene object. Through OStream we got cout object. Okay, scene object and cout object we got. Okay, similarly here iostream.h is a header file. Similarly fstream.h is also an header file. fstream.h file is an header file. In this fstream.h header file we are having ifstream, ofstream, fstream, fstream base. So this whatever the derived classes are there, again this ifstream derived class will be inherited by ifstream derived class. Okay, means this ifstream will become a base class for ifstream derived class. ofstream will become a derived class for this ofstream base class. Okay, so now again this fstream base class will be there. So this is a hierarchical representation of a stream. So please try to remember this diagram. Okay, you try to draw number of times so that if they ask streams you can write this one. So go through all these things. The unformatted standard IO operations. Okay, you are having some IO operations: cout, scene, cerr, clog. So cout, you know, cout and scene, you write any program, okay, based on cout, you have to use cout. Okay, in it the cout object is a connected to the standard output device, which is usually is a display screen. Okay, so yeah, you go through this is a theory. Yeah, if they ask what is unformatted standard IO operations, then you have to write this one. Unformatted standard IO operations are scene, cout, CERR CLog. You write any program, okay, you write any C program, whichever you are thinking perfect, you write that program. In that you should have cout, any small program only, at least you write cout welcome, okay, you write cout. In cout you type hash include iostream.h, hash include conio.h, okay, white main function cout, you write, okay, in cout what you will write, cout welcome to BSc, you can write, that is enough. Next, scene. What is scene? Scene is an iStream class, is an instance of iStream class. Scene object is connected to the standard input device, which is usually is the keyboard, which usually is the keyboard. The scene is used in conjugation with the stream. Scene name and object, okay, here you write a program, simple program, hash include iostream.h, hash include conio.h, void main function int x comma y, uh, okay, int x comma y, cout, enter the values for x and y, scene x, scene y, okay, scene x, okay, and y, okay. Then what happens, the output you can, okay, the values you can give through keyboard, okay. This ends the program here also. CERR is nothing but the same cout program. Instead of cout you can write CERR, you write the same program, okay. Cout ki em program also adhe program randi, in the place of cout you write CERR, okay. It CERR also displays the output only, okay. In CERR also it will display the output, but CERR is an instance of OStream class, okay. It is like OStream class. Here you have to CERR and CLog, so okay, both OStream classes only, CERR and CLog also, okay, output cout, like cout only you can write this one, but in the place of cout you use CERR and CLog. You write CERR and write one example, again you write CLog and you write one example. Instead of cout you write CLog and write one program example. So to work this one, what we require, you read this one, you will try to understand, okay, what is the buffer is filled or until the buffer is flushed, you can write this CLog and all these things, it is there, okay. This one, so this you can find in a fstream.h header file. Instead of hash include iostream.h you have to use hash include iostream.h, and also you have to use a hash include fstream.h, you have to use, okay. If you use fstream.h header file, then it will work. CLog and CERR, okay. So so I'm ending this video here. So already, so I have almost covered, almost not, I have covered all the important questions of third unit, and I have I have completed all the topics of a third unit, okay. So this ends the third unit. So all the best, please go through the video number of times so you can clearly understand. So in the very very important topics are inheritances and the polymorphism. In polymorphism, function overloading, object overloading, and access specifiers, and then dynamic memory allocation, okay. These are all the very very important questions, okay. Okay then, thank you.